All right, we're moving on to lesson 9.5. We're going to be using a process called completing the square to help us solve quadratics. So perfect square trinomials are pretty special because perfect square trinomials allow us to factor, in factored form, perfect square trinomials end up being the square of a binomial. And that is super useful because if we can have the square of a binomial on one side of a quadratic equation, on one side of a quad, then we can solve the quadratic. We can solve using the square root property. This should be feeling a lot like a previous lesson we've talked about, solving quadratics through factoring by using the square root property. All right, so let's just think about that. Perfect square trinomials are pretty special things. So let's examine the pattern for perfect square trinomials. So if I have x squared here, and I'm just going to, for now, and I have 25 out here, you should be pretty okay with thinking about what needs to be in place. Obviously, we need to have an x right here, but what must be in order for this to be a perfect square trinomial? Square root of the first term is just x. Square root of the last term is 5. 5 times x, and we double it, 10x. So if b equals 10, x squared plus 10x plus 25, we have a perfect square trinomial that factors into x plus 5 squared. So that's super useful. So what is the relationship? What is the relationship between b and c in a perfect square trinomial? What is that? I'm asking you that question. What is the relationship between b and c? Well, if you have 1/2 of b squared, that equals to c, right? In this case over here, 1/2 of b is 5, and 5 squared equals 25, and that equals c. This is, of course, only if the leading coefficient, which is a, is equal to 1. This is only in that case. All right, so let's just think about that for a second. Can you tell me what we must put in here? So I have x squared minus 8x. What must c be in order for this to be equal to a perfect square trinomial? Okay, so we notice that a equals 1. Check, our leading coefficient is 1. So all I have to do is take 1/2 of b, that's dividing by 2, and I have to square it. All right, so 1/2 of -8 is -4, and -4 squared is equal to 16. So if c equals 16, we end up having a perfect square trinomial, which is super useful because then that means this thing would factor out to x minus 4 squared.